This video is for topic 4.6, Introduction to Titration. The objective for this topic is to identify the equivalence point in a titration based on the amounts of the titrant and analyte, assuming that the titration goes to completion. So titration is something we're going to talk about a lot more when we get to acids and bases and acid-base equilibria. This is just the introduction, so how to read and analyze a titration curve. We do a titration to determine the concentration of an analyte in solution. So when you do a titration, the important point, so there are two important points in the process. So the process of a titration is you have a known amount in your burette, you have an unknown amount in your Erlenmeyer flask. And you use your known and the amount of known reactant that you need to react with your unknown amount. And visually, we're going to look for a color change. We use something called an indicator to calculate the concentration of the unknown in your solution, or the unknown concentration of your solution. So there's 2 points that we're going to look at. There's the equivalence point and there's the end point. The equivalence point is when the analyte is totally consumed by the reacting species of the titrant. So that's when you have your unknown concentration in your Erlenmeyer flask, and everything in your Erlenmeyer flask has been reacted with the known amount from your titrant. So what's in your burette. Now, we need to know when this happens because most of our solutions are clear. Okay, so we use something called an indicator, and an indicator changes color based on a specific pH. When the color changes is called the end point. So there's two pieces. There's the equivalence point and there's the end point. The equivalence point is the reaction piece. So when your analyte is totally consumed by what's in your titrant, the end point is when the color changes for the indicator. Now, this all depends on pH. So what indicator you're going to use depends on what pH your change is going to occur. The most common one that we use is phenolphthalein. And so this chart here gives us a pretty good overview of some common indicators at what point they change color. You'll notice these are not right from one to another. There's an in-between kind of gray area. So there's definitely an art to doing a titration. And what indicator you choose depends on at what pH you want the change to happen. So phenolphthalein is our common one, and phenolphthalein changes from clear when it's acidic to pink when it's basic. I'm trying to think of what else we might have used. Actually, I don't know if we used any of these in regular chemistry or honors chemistry. I don't think so. I think we used a different one from our common ones, which is fine. But these are some common indicators that we can use to determine the colors, but it's all about the color change. So from yellow to blue, from yellow to red or pink, from clear to pink. Clear to pink is really easy because it's easy to tell from colorless to colored. Anything going from a color to another color is harder to determine. So when you titrate, on the left of your screen is an example of the setup. So we use a burette to dispense our standard solution. So that's the one that we know the concentration of, and it's graduated backwards. So it's graduated to tell you how much you've dispensed. So up at the top is 0, and down at the bottom is usually either 50 or 100, whatever the scale is. You read it the same way you'd read any other glassware. So you get down at eye level and you read from the bottom of the meniscus. But you do have to keep in mind that your amount dispensed is always going to be your final reading minus your initial reading because it's graduated backwards. There's usually some sort of knob at the bottom of the burette that allows you to control how much of the titrant gets, or the standard solution gets dispensed at a time. So you can open it up so it dispenses fairly quickly, or you can keep it closed or closer to closed so it dispenses by drop. that helps you get a really nice, clear point of color change. And then the unknown concentration is down at the bottom in your Erlenmeyer flask. So that's what you're ultimately trying to calculate. And then we can graph this as well. So we usually make a graph of pH and volume of titrant added or standard solution added. So this particular one has a strong base and a weak acid. And so when you look at your curve, the point where all of your analyte is consumed is this point right here in the middle. So that is your equivalence point. It's at that point where it's the most vertical on your pH range. If you end up with multiple curves, that means you've got multiple hydrogens going on. So you've got a polyprotic acid, so something that has more than one hydrogen to donate. We're going to look at those later. We're going to look at the point that's halfway to the equivalence point. There's all different parts of a titration curve that we can use to give us information about what is going on in our reaction. But for right now, we need to know the general standard setup for a titration. We need to know that the equivalence point is where the analyte is being consumed, or all of the analyte has been consumed, and then that we know we have reached the endpoint based on the color change of our indicator. And the goal is to have your endpoint and your equivalence point at the same pH, or as close to the same pH as possible, so that your endpoint tells you your equivalence point.